Hello, everybody. Today we will be talking about lovastatin. My name is Lauren. Let's dive on it. All right, so we're going to start off talking about our characteristics of lovastatin. So the trade name is known as lovastatin. There's the generic name is Mevacor, and the drug class is a dyslipidemia. So it's a HMG-CoA reductase inhibitor, otherwise known as statins. All right, kind of going into the cholesterol biosynthesis pathway here, we have our 3-hydroxy-3-methylglutaril-CoA, and that will turn into mevalonate through HMG-CoAse reductase. That is like the first step within the cholesterol biosynthesis pathway. Mevalonate will eventually turn into your 3-isopentyl pyrophosphate and go through these intermediates as well as using ATP to make that happen. Then your isopentyl pyrophosphate will turn into your dimethylallyl pyrophosphate, which is used as a precursor to this process here, which will turn into squalene using these intermediates. And then squalene will eventually turn into cholesterol throughout all of these intermediates as well. So there's a huge long process for cholesterol synthesis to occur, and cholesterol synthesis mainly occurs in the liver. So kind of going over the lipoprotein particle metabolism, you have your LDL receptors, remnant receptors, and HDL receptors within your liver here. And you'll also have LDL receptors on your peripheral tissues over here. So kind of what happens is that cholesterol synthesis occurs, and then VLDL is produced. And VLDL is, it'll enter the bloodstream. It is very low density lipoprotein. It is hydrolyzed by lipases on capillary surfaces. That it'll create free fatty acids, which are taken up into the adipose tissue here. Or it can turn into IDL, which is your intermediate density lipoprotein. Your IDL is your precursor to your LDL, known as low density lipoprotein, that is also known as your bad cholesterol. So your LDL is a major carrier of cholesterol within the blood. Your HDL over here will take the cholesterol that's kind of free floating in plasma. That cholesterol is there because dying cells, it gets released from the membrane, right? Or just released to storage. It'll pick up all that cholesterol and bring it back to the liver, kind of recycle it. All right, so kind of diving into our LDL receptors that were on the tissues and here, the peripheral tissues and the liver, those the little receptors, right? So kind of diving into like the process of that, you have endocytosis of LDL in order to create cholesterol that can be used either for integration into the membrane or it can be used as storage of cholesterol. So your LDL receptors will bind, or the LDL will bind to it, and this complex will get internalized within the cell. Then this will bind to a lysosome, which will hydrolyze the LDL to free amino acids, and cholesterol will be released here. When your cells die, cholesterol is released into the bloodstream because it gets released either from the storage or from the membrane itself. So that's bad. That is high cholesterol. If there is not a lot of the LDL, so like say that our body is intaking a lot of LDL, it won't all get integrated. There's only a limited number of receptors available. So therefore, the LDL will get backed up into the bloodstream. High cholesterol will be occurring as well. And so that's where lovastatin comes in. Our lovastatin structure, this is here, and then this is the active form. This active form looks a lot like the HMG-CoA reduced intermediate, which is also kind of like where the binding occurs for your HMG-CoA reductase. So that will inhibit that enzyme. The active site will not available and therefore mevalonate will not be produced. Therefore, that cascade of the cholesterol biosynthesis pathway, that just won't occur. So lovastatin will inhibit the HMG reductase, therefore decreasing cholesterol synthesis. Lovastatin can also increase the number of LDL receptors on both the peripheral tissues and within the liver. So whenever the LDL receptors get increased, you'll have an increased rate of extraction of LDL from the blood, and you'll increase the liver's extraction of LDL precursors. So mainly, lovastatin is increasing the need to take the LDL from the bloodstream, put it back into a cell, internalize it, put it somewhere else, don't let it float around in the plasma. This is what happens when LDL does not get put back where it goes, and it'll remain in the bloodstream. Atherosclerosis can be a major contribution of that. So it is a plaque essentially composed of lipids, calcium, cellular debris. Mainly LDL causes this. Atherosclerosis has the potential to lead up to either heart attacks or strokes because of these plaques. They can break off and cause clots somewhere else downstream of the artery. So very, very bad. We want low levels of LDL, higher levels of HDL to be healthy and prevent this from occurring. So yeah, this is the end of my presentation. I thought that was pretty cute. And here are my references.